Hello, you're welcome to my channel. Thank you for stopping by. Today we'll be learning together how to factorize algebraic expressions. Now, when we are asked to factorize an expression, we are required to do the exact opposite of expanding brackets. Yes, that's what we learned in the last video. Please check out the description box for a link to that video on how to expand brackets. But today we're doing the reverse. Now, to factorize an algebraic expression, the most critical thing you need to pay attention to is you need to use the highest common factor. What do we mean by the highest common factor? When you have an expression, you need to look out for that highest, that is the biggest factor that the terms in your expression have in common. So take for example here, question number 1. If you look at the two terms in this algebraic expression, yes, there are two terms. We have 33p and 22. To factorize this properly, we need to look out for the highest, that is the biggest thing that these two terms have in common. If you look at the two terms, we have 33p and 22. The biggest thing they have in common is 11. So I'll write 11 outside of this bracket. What do I mean they have in common? 11 can go in both 33 and 22 without leaving a remainder. That's what a factor is. All right. So 11 outside of my bracket. And then I open up a bracket and say, if I divide 33p by 11, what do I have left? 33 divided by 11 is what? 3. And then I put down my p because there's nothing to divide it with. So 33p divided by 11 is 3p. I write down my plus sign. And 22 divided by 11 is 2. So I'm done. I close my bracket. How am I certain I've done a good job? I need to be able to open up this bracket and go back to the original thing. So if I open up this bracket, that is expand this bracket, I'll have 11 times 3p, which will give me 33p, plus 11 times 2, which will give me 22. I've been able to go backwards, so that means I've done a good job. Okay, let's move on. Now, for question number 2, I have 15x minus 12y. What's the highest common factor of 15x and 12y? The variables are different, so I can't get a variable, but I can deal with the coefficient. So what is the highest common factor of 15 and 12? The highest common factor of 15 and 12 is 3. So I put down 3 here. I open up a bracket. 15 divided by 3 is 5. So I have 5x. My sign is negative, so I put minus. 12 divided by 3 is 4, and I put down my y. So if I'm going to factorize 15x minus 12y, it's going to result in 3 into bracket 5x minus 4y. Notice that when I open up the bracket, I go back to where I started from. That is my proof that I have done a good job. On to question number 3, it's kind of different, but it's still the same concept. Now, we need to look for the highest common factor. All the while, we've only been seeing our constants, our coefficients having common factors. But here, even the variables have a common factor. So let's start with the constant, the coefficients. The very first coefficient here is 18 and the second one is 12. What is the highest common factor of 18 and 12? The highest common factor of 18 and 12 is 6. Because that is the biggest number that can go in both 18 and 12 without leaving a remainder. Then I move on to, I have p squared and p here. What is the highest common factor of that? It's p, because p can go in both. And finally, for my third item here, my variable q, I have q in the first term and I have q squared in the second term. The highest common factor there that will go in both without leaving a remainder is q. Now I've been able to find out what is outside of my bracket. I open up my bracket and say 18p squared q divided by 6pq. You don't need to do it together, one at a time. 18 divided by 6, it's 3. P squared divided by p is p. Q divided by q is gone. So we just have 3p left in the bracket. Then I put down my sign. 12 divided by 6 is 2. P divided by p is 1. So I don't need to write down my p anymore. Q squared divided by q is q. I'm done. Then I close my bracket. How am I certain I've done a good job? If I open up this bracket, I'm going back to the original expression. You could try it. All right? Good. That's question number 3. Moving on to question number 4. Sometimes the coefficient is a fraction. This usually happens in this topic, and that is, I think, vectors. When you're dealing with vectors, sometimes you're going to have fractions in front of your terms, and then you would need to open up a bracket. So you need to be able to see your fractions differently. Now, we have 3 over 4 and 7 over 8. It seems that they are not the same thing. It seems the fractions are different, but I could write 3 over 4 in terms of its equivalent. What do I mean? I want to make its denominator also 8. To make the denominator 8, what do I do to my numerator? I multiply by, what do I do to the denominator here? I multiply by 2. If I multiply my denominator by 2, I need to do same to my numerator. So this question could easily have been 6 over 8 x cubed plus 7 over 8x. Now we can see it is possible to have the fraction put out. What is the common fraction here? The denominator is 8. So I'm going to pull out 8. This becomes 1 over 8 as far as the number is concerned. If you look at the variables, I have x cubed here and x here. What is the highest common factor of x cubed and x? That is x. So I have x outside and I open up my bracket. As far as the fraction is concerned, what is left of 6 over 8 if I divide it by 1 over 8? I've got 6. X cubed divided by x, I've got x squared. I put down my positive sign. And then I have my 7 over 8 divided by 1 over 8. I've got 7. X divided by x, it's taken care of already. So, invariably, my final answer here is x over 8. Opening my bracket, I have 6x squared plus 7. That's the final answer. I have been able to factorize that expression. Okay, now the final question we're looking at here is 6x cubed plus 2x squared plus 4x raised to power 5. Sorry, let me go again. The final question here, question number 5, is 6x cubed plus 2x raised to power 4 plus 4x raised to power 5. If you take a look at this question, you need to see that there is a highest common factor for all 3 terms as far as the coefficients are concerned. What number can go in 6, 2, and 4 without a remainder? Yes, you guessed right, the number is 2. Then we look at the x raised to power 3, x raised to power 4, and x raised to power 5. What can go in all 3 of them without a remainder? X raised to power 3. Now we can open our bracket. We have successfully identified our highest common factor. So opening up the bracket, 6x cubed divided by 2x cubed is going to leave us with just 3. 2 2x raised to power 4 divided by 2x raised to power 3 is going to leave us with just x. And 4x raised to power 5 divided by 2x raised to power 3 is going to give us 2. That is 4 divided by 2 is 2. X raised to power 5 divided by x raised to power 3 is x raised to power 2. If you're wondering how we're getting all of this, you might need to brush up your knowledge of indices. The link to a video teaching the basics of indices is in this description box. Please take a look at it. Thank you very much for watching and see you in the next video. In the next video, we will be looking at a very interesting topic, rearranging formula, what some other people call transposing. Have you subscribed yet? Please do. Bye.